Okay. With luck, that's confirmation that you're in the right place. Okay, I've gone and pasted the agenda into the notes page. Would anyone like to volunteer to try to take notes there since I've not been doing very well in some of the recent meetings? Hello, Giannis. All right, let me see if I can make this work. Okay, this is an IETF meeting. This is the Note Well slide. You're expected to be familiar with it because it applies to your participation in this meeting. All right. And let me go. Few more clicks, which I guess is proof my coffee's working this morning. This is the agenda. Um, so right now you're here in item 0, quick intro, and uh, time to bash the agenda. Under item 1, process-oriented topics, we're going to have some slides on the TSN queuing and scheduling mechanisms. The goal is not to get through all of them, but to discuss one or two of them in depth, about the same way that we discussed CQF in depth at the last meeting, both to understand sort of what mechanism is, and equally importantly, to in essence, debug the requirements draft so we understand what it means for a mechanism to meet or not meet the various sections of the requirements draft. After that, Antoine is going to do a presentation on bounded on his bound delay queue draft. Any comments? Anyone want to bash the agenda? Turles, go ahead.
Just to repeat what, if you haven't, folks here haven't read the mailing list, I've tried to see how we can capture, the work of these meetings on the wiki a little bit better. So let me know if that's useful. What else we can do, and add other mechanisms that you think should be in the list. Um, and then also we merge the two CQF derived mechanisms that we've been presenting that yeah, so I sent that to the mailing list. Thanks.
Okay, great. And we know from discussion in a past meeting that CSQF uses the same mechanism in the data plane, the same uh, scheduling queuing mechanism on the node, but has a different control mechanism and passes different information between the nodes. But I don't know yet what we ought to do about drafts to recognize that.
Yeah, I don't know yet what the authors there would like to do, but I certainly would love to try to propose some comparison to I think add further explanation about the pro and cons of either approach.
hmm I think that's a good sentiment, and like you, I'm not sure exactly what to do. Um, okay. Any other comments, or should we go ahead and dive into one of the TSN mechanisms and see what happens? Okay. Hang on here. Ah, okay. Xiaofu, you going to lead discussion on this? Hang on a minute. I need to negotiate with Meet Echo. Just a minute here.
Hi, David.
Oh, I can barely hear you.
Thanks for unmute my mic. Thank you. Can you help me share the slides?
Um, all right, hang on a minute. Xiaofu, I can barely hear you. Can
Okay,
anybody else,
so I
anybody
see
else
the
hear Xiaofu well? All right, I think you're going to have to yell at us. All right. Let's see.
Hi,
Do you
David.
want to go ahead?
Please go to the next page.
Okay. And you're coming through much better now, Xiaofu. You're very hard to hear earlier. Something just improved. Please keep doing that. Let's see. All right. So
Maybe we can go to directly to the TIS evaluation page.
which okay, this one.
Okay, this one.
Yeah.
So this slide give an overview of the TS evaluation according to the requirement draft. So let me begin from the first item. So for the item tolerate the time asynchronously, the evaluation is low because the all terminals and the network devices need to achieve nanosecond clock synchronization across the network to ensure that the GCL time of all outgoing ports is synchronized. For this item, I'm not sure if anyone has some more comments. I think this item is obvious, so I will go to the next item. For the item support the large single hop propagation latency, the evaluation is yes, because the link delay is naturally considered during GCL calculation. That is to determine the TAS transmission gate window position, and the GCL is independently installed on each node. Okay, if there is no any comments, I will go to
let's quick
next
check.
item.
Those sound like easy calls. Any comments or disagreement with 3.1 or 3.2? Okay, carry on.
Okay, if there's not any comments about these two items, for the next item, accommodate the higher link speed. The evaluation is partial. More precise time control. That means smaller time interval of GCL is required. That may exceed the capacity of the device. Some more detail of the explanation is that the GCL operation is based on the flows. So for a specific and specific cycle of the GCL, they may contain too much items due to the higher link speed. And the time interval is smaller, so they can contain too much items. Is there any comments for this item?
Johannes, go ahead.
Okay.
Yes, hello. Very generic question to the presenter. When you say time-aware shaper or refer to IEEE 802.1 QBV, it sounds like you refer to a particular use of IEEE 802.1 QBV, so which is the enhancements of scheduled traffic, because you said the jitter is ultra low and so on, but the enhancements for scheduled traffic provide you some form of programmable machine, so it can be used in one or another way. For example, you can even, with some other extensions, create a CQF-like behavior with this enhancements for scheduled traffic. So do you refer to a classic TDMA use of the enhancement for scheduled traffic in your evaluation here? Or it sounds a bit to me like that. Or do you have some other communication scheme in mind?
Sorry if I get your question clearly. So these slides of TS evaluation is based on the classical TS. That it means IEE 802.1 QBV is not contained any enhancement.
Sorry, can you repeat the last part?
So this evaluation is based on the classical TS mechanism, which does not contain any enhancement such as C-curve or C-curve.
I think this is understood, but you're using TAS or 802.1 QBV,
Yes.
which is the project name of
Yes.
P802.1 QBV. It's enhancements for scheduled traffic. So standard does not contain TAS. And it can be used in various ways. But for example, in 3.7, you say delay jitter is ultra low. And it really depends on how you use the gate control list. And my question is, therefore, do you assume 802.1 QBV is used in a time division multiplexing arbitration session?
Johannes, I believe he already said yes to that question.
Oh, okay. I couldn't hear this. It's really hard.
Yeah, I'm pretty sure he said yes to that question. And beyond that, there's a separate, we had a separate discussion at the prior meeting about CQF. So if TAS were used to implement CQF, I would suggest referring to evaluation of CQF.
Yeah, that's something I simply try to understand. So if the answer is yes, then I understand this slide here better. Thank you.
The answer is yes. Troilus?
Just for completeness, are there any other relevant profiles of TAS between TDMA and CQF that we should take a look at, Johannes?
I'm not aware.
No,
I thought the question was for me.
yeah, the reference is just QQA.
Paulus was a question to me.
Let's say it's also a question, Johannes. Go ahead.
Okay. Not in a standardized way, though this classic TDMA is, I think it's likewise not really normatively standardized. The CQF is an informative annex as well, so people may use it differently, but nothing I know from my memory from the IEEE 802.1 Q standard.
Okay. So it sounds like TDMA and CQF are the only interesting uses of this. If somebody has another one, I will provide my standing answer for that. Send draft. Xiaofu, keep going.
Okay, thank you. So for the next item, be scalable to the large number of flows. The evaluation is partial. GCL calculation for all flows and the control plane is MP hard problem. A GCL may contain too many items due to too many flows. It can maintain queues per traffic class and does not restrict the strategy of flow entering traffic class based queues. Is there any comments? Okay, for this item, the main question is the calculation is complex.
Yeah.
So
Actually,
for the
I have
next
a question.
item,
Actually, I have a question there, but the
okay.
question is to Peng on the requirements draft. And I'm going to apologize because I probably should know this. I don't. Peng, how does the requirements draft treat individual flow scheduling versus traffic class scheduling?
Well, I think there's no text to distinguish traffic and flows, I think, in the current version of the text.
I'm sorry, you need to say that again. You're very quiet.
Well, I mean, in the current version of the text, there's no result or no discussion about how to distinguish the traffic and the flows.
All right. It sounds like that might be something that would be useful to add, because if I understand what Xiao Fu has written, he said that TAS will not scale to a large number of flows because the control plane problem is very bad, but TAS per traffic class will scale to a large number of flows by virtue of traffic classes. And I guess we need something in the requirements draft to talk about use of traffic classes versus individual flows. Does that make sense?
Yes, but I have a question or concern about to evaluate TS because in my mind, as I know, I don't see any extension to TS to use in a large-scale network. If I'm not wrong, I think in most people's mind, they think it can't be used in the large-scale network. So there's no just trial or more work on that. So we can just give some inference, I think.
I don't think there's a problem there. I mean, for example, there are two clear no's in the evaluation column, which suggests that TAS in a large-scale network is not going to work. However, one of the purposes of this exercise is to better understand the requirements draft. And that's why I'm raising this here, because I would not be at all surprised to see traffic class versus individual flows turn up in the evaluation of some of the new mechanisms that are appropriate for large scale networks.
Well, yes, we can give some explanation, but that is just to express my little concerns about it.
Okay, and
Yeah.
the concern is completely valid. In encouraging this evaluation exercise, I'm not believing that any of the TSN mechanisms are going to be completely suitable for large scale networks, but it does serve the purpose of understanding where the gaps are and where some refinement to the requirements draft will help us work through the new mechanisms.
Yeah, I agree with that.
Okay, Torlis?
But I'm a little bit surprised of bringing in traffic classes. So I'm not quite sure that we've done that in the past or as goals, right? I think when I was talking, for example, about TCQF, I was just saying that the scaling behavior that we achieve is similar to that what we have with traffic classes, but that was just meant as a comparison form, but not as specifically saying that here there is a DETNET idea for traffic classes, which I don't think we have, or do we?
Taurus, I don't understand clearly your question, but for TLS mechanism, it actually contain 8 traffic class. For example, the best afford traffic class is also included in it. The TS can contain the GCL to set the state for the for each traffic class to send the traffic.
Isn't that rather than what I would be calling, what I think I've also seen in other papers being called priorities in terms of that an individual flow belongs also to a traffic class, and then the behavior, the latency, throughput, whatever it is, for different traffic classes is given different parameters there. So it's not independent of the per flow behavior, but it's an additional parameter of each flow.
Well, and more importantly, if I
Yeah, you are
understand,
right.
go ahead, Xiaofu.
Okay. I think Taurus is right. The TS mechanism is actually operate based on 8 traffic class, and multiple flows can share a single queue, specific traffic specific queue. For example, the flow 1 to flow 10 can share the uh, the queue with a specific traffic class, but the flow 1 and the flow 10 arrive at the same node at a different time. So they arrive at the so the share the different time interval of the GCL. So that is my opinion.
Okay, so it sounds like we need
Or
to say, I'm sorry, go ahead.
okay,
Okay, so it's,
I have
yeah,
give my opinion. I don't know if my answer has uh answered the police question.
so I think where we are here is the requirements draft will need to say something about traffic classes and aggregation. In particular, if the GCL calculation were per traffic class instead of per flow, that might produce better scaling.
I'd rather say that
The calculation is actually per flow.
David, the GCL is
So
per traffic class. So the transmission gates are per traffic class.
Mhm. Okay,
but isn't it true that we uh, uh, okay, so in the control plane we need to capture per flow information and calculate per flow which each flow given a traffic class. And then in the forwarding plane, we have like in the derived solution like CQF, TCQF, and so on. We only have the different traffic classes.
okay. Johannes, go ahead.
Yeah. Thank you for your comment, David. What you said before, this is like that's how I would see it. Also a bit along the lines of how is QBV used here. If you make bigger windows to put in even the traffic of an entire traffic class, it's getting a bit relaxed here. I've seen such use, but as said, not in the standard.
Okay. All right, so I think the evaluation is reasonable, and I think we do need to say, as mentioned earlier, do need to say something in the requirements draft about use of traffic classes and flow aggregation for scalability. Okay, let's go ahead and move on to high utilization.
okay. For the item tolerate the high utilization, the evaluation is partial. The time interval of GCL with dedicated bandwidths reserved for TSN flow is inclusive. So if the TSN flow does not send the packets, the bandwidth is wasted. Any comments? So if there are not any comments, I will go to the next item. For the item, prevent the flow fluctuation from disrupting service, the evaluation is low. The recalculation of the GCL are more complicated and requires to update the GCL frequently on all nodes that the flow passes through. Any comments? So for the last item, be scalable to a large number of hops with complex topology. The evaluation is partial. More complexity of GCL calculations due to NP-hard problem that is related with hop count. However, end-to-end queuing delay is negligible. That means end-to-end delay mainly depended on link delay. And at the same time, the end-to-end delay jitter is ultra low. Any comments?
Okay. Let's go on to the next one and see what we. Okay, Shafu, you want to talk about the credit-based shaper evaluation?
Okay, if there's the time to share, I'm happy to do it. Okay. This is credit-based shaper. The standard is refers to IE802.1 QAV. For the first item, tolerate the time asynchronously. The evaluation is yes, because it does not rely on time synchronization or frequency synchronization. It is because it is a read-based mechanism. For this item, any comments? Okay. For the next item, support large single hop propagation latency. The evaluation is also yes. Link delay does not affect the read-based shaping logic of CBS. Okay, for the next one, accommodate the high link speed. The evaluation is also yes. More buffer space is required to serve more service bus accordingly. It's almost impossible to cause burst storm by a single interfering frame because link speed is high. So in this case, it may not necessary to be combined with ATS. To be combined with ATS. Any comments for this item? So for the next one, be scalable to the large number of flows. The evaluation is partial. The shaping of CBS is based on several traffic classes for aggregated flows. It may need reshaping ATS to avoid the Bastini's cascade for each class. This can be found in the paper as it is indicated.
Yes, and our traffic class discussion that we had on TAS also applies here. We'll need the requirements draft will be updated to address that topic.
Okay. For the next item, tunnel with a high utilization, the evaluation is yes. It is said that the pre-configuration of bandwidth limit for each traffic class. The best effort flows can use the unused portion of the reserved bandwidth of TSM flows. Any comments for this item?
Johannes, go ahead.
To the item 3.4 item 1 and 3.4 sub item 2. Just for my clarity, 3.4 sub item 2. When you say pre-configuration of bandwidth limit, do you mean setting an administrative idle slope value to the associated credit-based shaper?
Yes, idle slope.
Okay, thank you. And the second question on 3.4.1 is, I don't know I can't remember if it's a title, but the contribution there referred to in item or in the bottom line, number 1, latency and backlog bounds. Is this the contribution or the paper where CBS and ATS is combined in a single port? So they are serial, the first ATS shaping followed by CBS shaping.
Yes, it is a paper to discuss to combine the ATS and the CBS to work together to avoid the Bastini's cascade for the for specific class.
Yeah. Okay, if it's just to give you a hint, if it's the paper where CBS and ATS are entertained for the same traffic class in the same bridge port or end station port, this is nothing that is specified by IEEE 802.1q, this combination. So this mechanism is not standardized, this combination.
Yeah, I agree.
So just a remark.
But
That's
this
all
paper
I have
is
to say.
useful to. Yeah, thank you. Thank you. I think the combination of ATS and CBS is useful for some scenario. Because the Bastini's cascade problem is actually existed as the ALFC 9320 has also discussed this combination to avoid this issue. Okay.
If it helps, there's no requirement that what we discuss here have been standardized. I think what Xiaofu here has done by pointing out that there's an interesting combination that improves CBS is just fine.
Yeah. Yeah, okay, I will go ahead. For the next item, okay, the next item I have done. So for the next item, prevent the flow fluctuation from disrupting service. The evaluation is yes. Each service flow of class A or class B is permitted based on the bandwidth reservation. And the total amount of bandwidth reservation does not exceed the pre-configuration limit and not exceed the worst latency. So the resource reservation is based on the traditional bandwidth reservation. Any comments?
It sounds like the bandwidth reservation has to be based on worst case burst behavior for all flows occurring simultaneously. Is that correct?
Yes. Yes,
Okay,
so CBS is a read-based mechanism. So the worst latency may be overestimated.
Mhm. Okay.
Okay, for the next item, be scalable to a large number of hops with complex topology. The evaluation is partial. On each node, the queuing delay is overestimated, basically inversely proportional to the idle slope due to non-work conserving behavior. Thus, the end-to-end delay is large. This means the worst end-to-end delay is large. Any comments?
Not hearing any. It sounds like you've done a good job here. Thank you. I want to go insert a process question here. So for everybody who is proposing a new queuing and scheduling mechanism, you've now seen evaluation walkthroughs of 3 existing mechanisms. Do you believe you've seen enough in those walkthroughs so that you could prepare a chart like this for your new proposal?
David, to make it more clear, the each item of the table should be the same as this one or the previous one prepared by Yizhou, or we can list the item we think is very crucial to evaluate.
I think I'd want to see a chart like this for each proposed mechanism, and then I don't think there'd be a problem with another chart pointing out interesting and interesting characteristics of the proposal that aren't captured here. Would that be okay?
Oh, it's okay for me. It means that we can take this charter as a beginning and we can end something we think it's more interesting for some specific mechanisms if we like, right?
Yes, although I would ask that the the more interesting aspects be limited to a single slide, because we're going to have to do compare and contrast among the new mechanisms to figure out which ones solve which problems and what to take forward.
Yeah, okay, understood.
Okay, thank you, Shusong. Turles or Iju, do you want to comment on CQF? Or sorry, TCQF? Turles, go ahead.
The mic button is always your friend. Not no, I think at most I'm struggling with whether this list is that we have in the requirements draft complete enough to do a useful comparison. So I think the CBS one is particularly interesting, and I have to sit a little bit longer on it to see what may be missing in terms of what the new proposals that we have overall are improving on this one. But certainly, I think it must be possible to start with this.
Okay, sounds good. And if you see something that ought to be improved in requirements draft, please send notes to the list. I'm sure Peng is very interested.
But you do know that I had proposed at last IETF meeting a draft which had a more detailed list of evaluation criteria, right? Without making that be necessarily each of these criteria be a requirement. And I think that that's an easier starting point than to coming up to these evaluation judgments. That's I think what I'm a little bit struggling with.
Let's see, I need to choose words carefully here. I'm looking to make progress with some initial evaluation that is tractable and comprehensible across a variety of mechanisms we're going to be looking at. So at the moment, I think, let's see, to put it another way, I greatly appreciate the depth of the draft you wrote, Torlis, but at this point, I want to make sure that we've encompassed the breadth of the proposals, perhaps before diving into that depth. Okay, Peng, go ahead.
Well, some points here. One question that if we only use CBS, can it guarantee the latency? For example, if we see the result of the chat, we see some of the evaluation results were yes, and some of them were partial. So it will give impression that it may be used into the large-scale network, but it may has its own problems, such as latency guarantee and also some efficiency issues, I think. That's one of the point. And the second one is that I recognize the requirement 3.4. The second point of it tolerates high utilization. It's a relative new points that is added into the text, and I think in these slides, the notes, I mean the evaluation method is a little different from the previous one for the TS. I need to explain that for this point, it means if there's no more bandwidth can be used into for the DETNET flows, how it can what more work can be done to scale the capability. And now I think maybe there's a little problem for the requirement draft for this point. So it lead to the result that, for example, for this one, it says to set the pre-configuration of bandwidth limit. And please go to the previous slides.
So which slide do you want to go to?
For the TS slide.
There we go.
Yes. And for this point, it says if the TNS flow doesn't send packets, the bandwidth is waste. So so I mean it's different to evaluate for this point, but maybe this point has its own problem and not so major in at this stage. And I will think more about this point for this requirement.
Okay.
Yeah. So just 2 points. One is for the CBS itself, and the second one is for the requirement 0.4.
Okay, I try to answer the second question first. For the total rate high utilization for this item, I think what for TS and for CBS, the evaluation is similar. It says that if the resource is reserved for the deadnet traffic, if there is no traffic really sending, the bandwidth can be used or not for the best afford traffic. For TS, it is not, but for CBS, it can. So the evaluation result for these two mechanisms are different.
Okay. Okay. Sorry. I understand what you mean. You use the same evaluation method, but really don't get the true requirement of this one. But I don't mean the requirement is correct now. You mean that the to reach a high utilization of the bandwidth, right? But now in the text it says if the traffic go to for example more than 17% or just up to 100%, and how to treat more flows of it. As but we can just leave this point for the next work.
And Peng, I think one of the concerns here is that Yizhu's discussion of dead time in CQF would detract from meeting this requirement. I think that would be an example.
Yes, I know that I write it in the proposed text, but here's the concern that if it's fired to other methods, for example, TCQF solves the problem of CQF. So we propose the requirement, but I'm not sure if others propose the method because they may don't have the original method. Okay, if we use the TCQF and it reached the 100% of the bandwidth, and how to further further optimize itself.
Was there a question in there?
I'm not so clear about this point. I mean, the new proposed requirement is correct or fire to others kills mechanisms, and we think we can
Okay.
use more time to really discuss about it with the co-authors
Perhaps-
first. Yes, yes. I
perhaps
just
take a-
yeah. Okay.
I'm sorry. Okay. Perhaps take that discussion to the list. Turles?
With respect to the requirements, looking here at CBS, I think the one big thing we're missing is a requirement about jitter that is lower than, you know, the maximum latency minus the physical link propagation latency. So because I think that's the key differentiation, of course, between the current asynchronous mechanisms like CBS and the more synchronous mechanisms, which is most of the others. So I think that's something we need to add in the requirements and the evaluations. And then going back to the evaluation overall here, I think the problem that we have with this, which is I think an excellent you know, understanding from, or you know, that's very good that these evaluations were done here on this basis, that CBS and TAS are by themselves, I think, not really mechanisms in the way I think I would have imagined mechanisms, but rather the building blocks, right? So in terms of TAS being building blocks that can be used for TDMA or for CQF, and CBS being building blocks for, and I think that's the question. What are the profiles of that other than ATS, right? It seems that the evaluation here seems to imply that you can leave out on the hops or on the flows where you don't need it any of the ATS complexity of reshaping, but I'm not sure if that's really a feasible deployment model or rather just a theoretical option. Okay, let me try to rephrase that into an explicit question. Are there any known deployment profiles of CBS other than ATS in terms of the, you know, configured hop by hop behavior on actual networks?
CBS is used in the audio video bridging, so I'm not sure I understood your question in relation to ATS. So there are AVB has been deployed and CBS is used out on the field.
Okay.
So
Johannes?
then we have two profiles, so to speak of, right? AVB profile and ATS profile.
Yes, it's not a lot of CBS.
Sorry, go ahead. So repeat audio.
Yes, ATS is not a profile of yes. My understanding what a profile is. If you put it side by side with AVB, it's definitely not a profile. ATS is not a profile of CBS.
There's a separate slide in ATS that I've avoided going to mostly for time management reasons. And also because I thought that after we got through three of these examples, we could have a discussion about whether we have an evaluation framework that can be used for the new proposals. But there is a separate slide on ATS that Xiaofu did prepare.
But then, to be fair, should we remove the option of mentioning ATS here in 341 and simply say no there, so that you know, we don't mix up things when they really aren't meant to be, you know, at least even a profile, right? So 341, change that to no and remove the ATS option there and just capture what ATS can do for ATS separately. Wouldn't that be clearer then?
I'm not sure it changes to no, but it might reduce the scope. Might reduce the scope of partial. Because if you remove the reshaping, you're effectively imposing some limits on the behavior of the aggregate, which in turn propagate back to the flows that have been aggregated. So I don't think it changes to no, but it might is in essence what I'm saying.
Yeah, and then I think it also impacts 3.7, right? If we remove any shaping, then 3.7 will also be even more difficult.
Okay.
But in any case, however we adopt the evaluation, right? As Johannes said, if ATS is a separate spec and the reshaping of ATS is really, you know, not within the scope of CBS proper, then we should assume CBS evaluation without it.
Certainly a possibility. Zhangdong or Janu, haven't heard from you about whether you think we have an evaluation framework that you can use for your proposal. Any comments? Go ahead.
Yeah, I can prepare such a slide with regard to the C-score. Actually, I'm preparing a separate draft for C-score for the presentation of the July meeting. And I will also prepare such a evaluation slide in that July meeting, I think.
Yeah.
Thank you.
I think that's good. Peng, what is a reasonable time frame for updating the requirements draft so that all of the slides on the new proposals are prepared against the new version of the requirements draft?
Well, I guess it has some update, but not really so much, I think. And
Okay, one of the reasons for asking is we have 4 weeks until our next meeting because the 2 weeks from now slot was taken out by a US holiday. And so there should be time there to both update the requirements draft and leave enough time for the folks working on the new mechanisms to prepare this sort of evaluation of each of their mechanisms based on the new requirements draft.
yeah, so sorry, what about the question?
Okay, so the question is, when do you think a new version of the requirements draft could be posted that would be
Oh,
suitable
okay.
for doing this sort of evaluation of the new mechanisms? I'm sorry, I'm not being clear this morning. I need more coffee.
I think based on the current discussion, maybe 1 to 2 weeks, within 1 to 2 weeks, we can solve the current problem, I think.
Okay, let's
But
make sure.
yeah.
I'm sorry. Go ahead.
So big point. I wish that every quarter of this draft can really review it and get the consensus that we can. It's really stable now. Yeah.
Okay, let's target about 2 weeks. I'm thinking of July 5th, which is the Wednesday in about 2 weeks. It's just after the US holiday weekend. And if we can get it done before then, so much the better.
Okay, sure.
Thank you. Okay, Xiaofu, we're going to skip I'm sorry, go ahead.
Okay, I understand. I just found the. Do you think if we want to add a new requirement to discuss the high speed link, the high link speed interwork with the lower link speed, because the real network is from access aggregation and backbone network. The link speed is different.
Sorry, I don't understand why we talk about a lower link speed. Lower than what? Okay, first, the higher link speed is compared to a LAN, a local network, I think.
Because the traffic engineer path is end-to-end, that may pass through the access network, the aggregated network, and the backbone network. In these networks, the link speed are different. So the proposed mechanism should support the interwork between the higher link speed and the lower link speed.
Well, yes, I get your points. First of all, when we propose this requirement, we just compare maybe a local network to a backbone like scale network. So it become a higher link, and in fact, you'll see when we consider about the end-to-end link, the link speed are different. One of the methods I think we can change the name, for example, accommodate the different link speed, but it will be a little, have some relation to 3.8, I think. Or maybe you can provide some text briefly to demonstrate the problem. I think.
Try to provide the 2 minutes.
Yes, and maybe 1 or 2 paragraphs, and we can see how to merge it into the text, or if or whether it need to be merged into.
Okay.
Okay, and I'll note a comment from Antoine in chat that he thinks this mechanism is reasonable. Any final comments before we switch over to Antoine's presentation? Okay, Janos, can you share Antoine's presentation? Because it should be preloaded. I unfortunately have to leave at the bottom of the hour, so Janos is going to take things from here.
Okay. Can you hear me well?
Yeah, I can hear you. Janos, can you share the slides via Meet Echo?
Otherwise, I can share my own screen if it's easier.
How about you share your own screen, Antoine? Because
yeah,
if you're relying on me to do it, it's all going to vanish. Okay,
yeah, I will
there we
do
go.
that.
Thank
Okay.
you.
So
Sorry about
yes,
that.
no problem, no problem.
I apologize on behalf of my day
So
job getting in the way.
no problem. We all have a day job that gets in the way somehow. Okay, so I will share my entire screen so you get to see. Okay. Great. Can you see the slides properly?
Yes.
I don't hear. Okay. I'm very grateful of the working group to give me the opportunity to present a draft that we published a few weeks ago. This draft is entitled Enforcing End-to-End Delay Bounds via Queue Resizing. This is a joint work with my colleagues Anne, Sebastian, and Paulo. They are listed in the draft. And I will take the opportunity of the presentation today to present you this draft. I will use a very original agenda that will follow the structure of the document, so you know where we stand at a given point in the presentation. With no further ado, I will go to the introduction. So I guess people in the IETF-DETNET working group are already aware that there are some use cases for deterministic networking and for bounded latency over large-scale networks, because otherwise we wouldn't have the discussion we had today. One of the use cases that we see in the consumer market for bounded delay without the jitter constraint is online gaming. In fact, in online gaming, in massively multiplayer games, the developer of the multiplayer platform is interested in having a solution which enforces deadlines for actions that players do, and they don't really care about the jitter as soon as the deadline for actions is met, because the duration of some actions that the avatar of the players perform in the video game can accommodate the smooth the jitter that comes from a variation in the delay for incoming packets. So if we look at the chart that is shown on the right, that is taken from 3GPP TS23501, we are targeting use cases that are located at the top of the table. Those use cases have a specific packet delay budget, but they can accommodate some burst, so jitter, as soon as it's controlled over a default averaging window. And we differentiate those use cases from typical industrial TSN or deterministic networking use cases, for instance, discrete automation, intelligent transport system, or high voltage electric distribution, which are located at the very bottom of the chart. So the thing that you need to take from this introduction is that with the mechanism I'm going to present to you today, we are only looking at enforcing latency bound over network, but we are not interested in maintaining jitter bound. So this is a main draft ID. We cover this gap between TSN or deterministic IP technologies, which are used to enforce both latency and jitter guarantees at a cost, sometimes centralized management, a need for synchronization in small-scale network, complex queuing management, complex traffic shaping mechanisms, and more traditional quality of service enforcement mechanisms that enforce latency properties on average. For instance, with active queue management, you can vary queue in order to meet some delay targets on average, but not in absolute. So we are in between those two families of solutions. So in the rest of the presentation, I'm going to present the draft in 3 parts. First, I will present you how we designed a dynamic queue capacity adaptation mechanism. Then I will present you a signaling method that is heavily inspired by RSVP that we use, that a source and destination can use to reserve capacity and enforce end-to-end delay for some flows. And this is done by reserving capacity in specific queues in the node. And then we'll present you how we adapted RSVP to the signaling mechanism that we proposed earlier. Okay, so bounding delay at the switches. So first, I need to show you what are the rationales behind our idea to perform end-to-end delay, enforced end-to-end delay bound by acting on the queue depth. In fact, this from network calculus, we know that if queues are served as first in, first out, and the buffer has a capacity that is given by BE to the K, the delay can be expressed as T0 plus the capacity over the committed information rate. So what this formula gives is that given capacity for the queue, you can express the maximum delay that a packet will experience in a queue as an affine function of the capacity. If we have a fixed committed information rate, so this is the service rate on the queue. So in the following, if we take the committed information rate as a static value, and we adapt the buffer capacity by changing the buffer capacity, we can act on the worst queue delay. So for instance, here, if we increase the capacity of the queue, the worst queue capacity delay is increased. If we want to decrease the delay, we have a decrease in the buffer capacity. So we took from this idea and looked at the PISA architecture for switches. And if you look in the PISA architecture and you look at the packet forwarding engine, you can abstract the packet forwarding engine as a set of queues that can be of a variable capacity that are served by a scheduler, and the scheduler can adopt a set of disciplines for serving the different queues. One of those disciplines is deterministic round robin, meaning that each queue is served for a specific period of time over a period. So if we combine those variable buffer capacity queues and round robin deterministic round robin queue scheduler disciplines, then we can express the maximum sojourn time of packets in queues as a formula that is given at the bottom of the slides here. So the maximum delay is constant T0 plus factor here that depends on the capacity of the queue. So now that we presented how adapting the buffer capacity can help enforcing the delay, we need to put this mechanism in place into a system in which the queue sizes are not static and set at the startup of the network equipment, but that are adapted on the fly depending on the demand for reservation of capacity on the switches for flows for which we want to enforce end-to-end delay constraints. So we start from a system in which the queues have a variable capacity, and those queues have two occupancy thresholds. A nearly full occupancy threshold, for instance, when 80% of the queue is occupied, and a minimal occupancy threshold, for instance, when 20% of the queue is occupied. Then we operate a system like this. In each equipment, you have a set of queues. Those queues are occupied by, and in those queues, we have some reservations for capacity to serve flows for which the node has committed to respect a maximum delay at the node. Whenever a request for a deterministic delay queue capacity allocation arrive at a node, either there is capacity in a queue that and the node can respect a delay contract that is compatible with the end-to-end delay reservation that is requested. So that's fine. We just place a temporary reservation and we are good to go. But if we are in two problematic cases, we look at the thresholds. The first problematic case is that we can't serve the reservation for a flow because the delay that is requested that the flow needs to respect is too low. Then we look at the various queues in the equipment, and if one of the queue falls below the minimal occupancy threshold, we say whether we can reduce the capacity of this queue to meet the delay constraint of the reservation. And then we allocate the reservation to this queue for which we have shrinked the capacity. On the other hand, if a reservation for a flow cannot be accepted because too much capacity is requested, then we look at the queues for which the nearly full occupancy threshold is passed, and we see whether we can increase the capacity of the queue while respecting the minimal delay contract for the reservations that are already allocated in the queue. I made the schema to present those mechanisms. So this is the adaptation of the queue to meet the delay constraint. So here we see that this queue is occupied below the minimal occupancy threshold. We see a demand arriving here for an end-to-end delay that is 40 milliseconds. The queue can serve end-to-end delay for 50 milliseconds, and this minimal contract is 50 milliseconds. We are going to reduce the capacity in order to meet the maximum end-to-end delay for the queue and accommodate the reservation that is requested. On the other hand, if now we have a queue that is nearly fully occupied by a set of reservation, and we see a demand arriving for a capacity that exceeds the capacity of the queue, we look at the minimal contract for ongoing reservation in the queue here. We compare it with the maximum end-to-end delay. For instance, here there is a difference by 10 milliseconds. We can increase the capacity of the queue while meeting the minimal contract and accommodate the reservation that we received. Okay, so this queuing adaptation system is maybe very simple. It's far less complex than queuing systems that are involved in used in IEEE TSM initiatives. But the advantage is that they can be used in more simple devices and don't require any synchronization. So now that we are able to adapt buffer capacity in the different equipments, we need a signaling mechanism to signal the requirement for end-to-end, the reservation for capacity to serve flow with an end-to-end delay constraint. So I will present the signaling mechanism we put in place by taking as an example the network that is presented here. So we imagine that node A wants to use a reservation protocol to send a resource reservation request to node F for a flow for which the maximum end-to-end delay requirement is 85 milliseconds and the maximum capacity, including the burst of the flow, is 2 megabits per second. So I'm going to present the signaling mechanism I'm going to present differs from RSVP in two ways. First, we allow the exploration of multiple paths in the reservation procedure. To the best of our knowledge, we tried hard to look whether RSVP, there was some document defining the behavior of RSVP in a multipath environment, and we didn't find it. I would be very happy if you have a pointer to such a document somewhere. And in our mechanism, we allow either the destination or the source to take the decision about the path to take for the reservation. So compared to RSVP, this is different because in RSVP, when you send a resource reservation message to a destination, the destination is on and the destination only is responsible for acknowledging the reservation and confirming it. So let's start. So A shapes a request and sends it to F through its two ongoing nodes, so A to B and A to C. The message here has a set of parameters compared to the message format that I presented in the draft. The message format that I present here is slightly reduced for the sake of BFT presentability. So the most important information in this message are the maximum end-to-end delay, 95 milliseconds, the end-to-end delay commitment, which is the contribution of nodes that have been crossed by the message to the end-to-end delay, the bandwidth, the capacity requirement, which is 2 megabits per second, and a record route field that records the route of the nodes that have been crossed by the message. Then this message, which is B and C. Here we see that, for instance, if I take the behavior of node B, compared with the message that you see in the previous slide, here B has allocated temporary reservation in its QQ1, for which the maximum delay is 20 milliseconds. And before relaying the request to its outgoing interface to reach F, which are B to D and B to E, it has added the maximum delay of the queue for which it did a temporary reservation to the end-to-end delay commitment. So we know that B takes 20 milliseconds out of the 85 millisecond maximum end-to-end delay credit. And it has added its identifier to the record route. So now we know that those messages went through A and B, and the 20 millisecond delay is taken out of the 85 millisecond delay credit. The same for C here. So now the message arrives at D and E. Here, D only relays one message because here its maximum, the maximum delay for its QQ1 is 40 milliseconds, and the difference between the maximum end-to-end delay of the message from C to D is 35 milliseconds. So there is no way D can serve this this reservation. But other message can go through. So they are relayed to F with the maximum end-to-end delay, the end-to-end delay commitment, the capacity, and the record route. Now we have two alternatives. So first, we make our protocol behave like a RSVP. It means that the destination is acknowledging and fixing the path that is reserved. So out of the three message signaling request messages that have been received, F chooses one message. For instance, the message for which the difference between the end-to-end delay commitment and the maximum end-to-end delay is the largest, and shapes a reply with the maximum end-to-end delay, the end-to-end delay commitment it has received, the capacity, and the explicit route. This message is relayed along the route that is given in the reply message to A. And after A receives the message, the flow can be exchanged following this route with respect for the end-to-end delay commitment. Then another method would be to let the source choose the path that is going to be taken. So this behavior, we ask F to reflect all the requests it has received with a reply stating the maximum end-to-end delay, the end-to-end delay commitment it has received, and the route that is taken by the message. Then those messages flow to the source, and the source can make its choice of the most appropriate reservation mechanism. Okay, so if you have seen this, if you follow this protocol, you know that the information that needs to be transported in those messages is very close to what needs to be transported in RSVP messages, and I agree with that. But the issue we had when designing the formatting of the information we needed in this protocol with RSVP is that if we want to stick to already existing RSVP objects, the encoding of the information can be tedious, requires some computation at the various nodes, and is not really direct. We looked after RSVP object that was suitable for deterministic networking. We encountered the document draft Rosen .NET RSVP TSN that expired a few months ago, and we wonder whether it would be appropriate to have a more direct encoding of the information that we will use in our signaling protocol in future versions. But for the current draft, we try to stick to the RSVP formatting as it stands today. The other oddity that we found with regards to the differences between RSVP and our signaling mechanism is that, to the best of our knowledge, there is no clear policy with regards to how RSVP is managed in a multipass situation. Besides, in RSVP, destination decides about the reservation, and whenever there is an error with a RSVP reservation, an error message is sent to the destination and sent back to the source. So this is not a very quick failover mechanism. So let's now look at the encoding of the request and reply messages in RSVP. So if you look at our signaling mechanism, the requests are mapped to RSVP pass messages and replies are mapped to RSV messages. In those messages, some information are very straightforward to encode. Reservation ID and flow ID are carried by session data objects. We found a limitation in the session data object about the identification of flows, because in RSVP, the identification of flows is based on 5 tuples. So if you want to send IP traffic while respecting end-to-end delay bound that is not tied to a specific transport protocol, this may be a problem with the identification of the flow. The record route list that is carried in the request message can be presented as a route record object in RSVP. The route list carried by the replies can be translated as an explicit route object mapped to in the RSV message. What is less direct in RSVP is the formatting of the maximum end-to-end delay constraint and the contribution of the various nodes to the maximum end-to-end delay. We found out that the best option we had was to convey the maximum delay with a sender tspec or a flow spec object, depending on the message, with a general token bucket tspec parameter and a guaranteed service rspec parameter. So I will show this message later. And the delay commitment by the nodes is carried by an addspec object, including a set of default general parameters with a fragment carrying guaranteed service parameters. So I will present the formatting that we have for those 2 parameters. So first, the maximum end-to-end delay. So in the RSVP RFCs, we found that there is a formula that is giving the end-to-end delay in a situation in which a P, which is the peak data rate, little r, which is the token bucket rate, and big R, which is the rate, are equal. So here the delay, the maximum delay is given by S, which is a slack term here, plus B, the token bucket size, divided by R. So the end-to-end delay requirement can be given by R, B, P, R, and S, and the capacity is given by the peak data rate P. So we can use this token bucket tspec and guaranteed service rspec parameters. So here is the tspec and here is the rspec to convey this information. But it's not a direct read from the router. It needs to do some computation. So we think it can be more simple. In the addspec object is a bit more complex. You have far more parameters, but the end-to-end delay commitment can be carried by setting the minimum path latency here as undetermined value specified by RFC 2215. Then we express the node contribution to the end-to-end delay commitment as something that is added to the dtot and dsum parameters. So those parameters are so d here and dsum here, while ctot and csum parameters are set to 0. So csum and ctot are set to 0. We think that this encoding is a bit complex, but as I mentioned earlier, we try to stick to the typical RSVP message encoding. But if this mechanism gets traction, we feel that there would be potential optimization with a cleaner RSVP object to carry the information. So I hope that this presentation triggered your interest in this document. I would be very interested in hearing from you about your interest in this draft. In the next steps, we are very well aware that there is ongoing work about the alignment of proposed end-to-end DETNET mechanism with requirements for large-scale DETNET in large-scale networks. So we are going to make the exercise that has been presented earlier to align to tell how the mechanism we present in this draft can respect the requirements that are presented in the requirement draft. Around the follow-ups, we are wondering whether there is interest in this document. We think that one of the major aspects of this document lies in the RSVP protocol mechanism that we use to accommodate with multipath situation or to allow both source and destination to take decision about the reservation. Maybe they belong to this draft. Maybe the group thinks that there is potential for separating those RSVP protocol mechanism and making them appear in a separate draft. And also, we think that there is an interest in having a cleaner RSVP object to carry information about deterministic network flows, and we would be motivated to work in this direction with the group. So thanks a lot for your attention. I don't know if we have time remaining for questions, but I would be very happy to get your feedback about the document, either today during the meeting or afterwards, directly by email, as you did earlier, or on the mailing list. Thank you.
Thank you. Yes, we have a queue. So Torles, please go ahead.
A lot. Interesting presentation. So maybe high level. I think the whole RSVP and control plane aspects might be better brought up to the working group at large and not this team. So unfortunately, David, our master of ceremonies for this list, for this set of meetings is gone, but Janos may join in as well. So I think we primarily want to focus on what happens in the forwarding plane, and without that necessarily being tied to a specific version of the controller plane. And so I had a hard time figuring out which type of changes in the forwarding plane you would want to do, let's say, as opposed to RFC 2212, which would be the forwarding plane for guaranteed service, which is what the IETF originally did in conjunction with RSVP. But just let me add two more points, because that's what I would like to have an answer from. But in general, with what you were talking about, RSVP itself does not specify where the RSVP messages are routed across in terms of multipath or what the path is. That is supposed to be exactly the same path that the traffic would take. So to do anything that you want to do, you first need to have a mechanism by which you can steer the traffic across different paths. And in native IP multipath, you can't do that explicitly, right? So if you use IP multipath, it means that traffic, for example, for different ports to the same destination, or to the different IP addresses to the same destination, would go different paths. So you need to rely on that. The explicit route object, for example, is from RSVP TE, so that doesn't work with IP. So there's all type of, I think, issues that you would need to resolve going forward. But steering the traffic to get to different path with different bandwidth might be actually part of a better solution for doing the DETNET forwarding plane. But I think it's highly unlikely that we would want to do anything for steering other than what the IETF has already done. For example, these days, segment routing with segment routing v6 or MPLS. So I think you may want to tack onto that. Thanks.
Yeah. Just a remark about this multipath aspect. Do you think that it would be feasible or even desirable to route RSVP pass message over IP with segment routing and different segments for the exploration of various paths. Okay.
So Torres, do you want to respond, or I mean, or should we move in the queue?
I'm sorry, I'm too old to still learn that. So I think in general, the problem I have with RSVP is that we already saw, more than 10, 12 years ago or longer, that we have scaling issues with RSVP in the network, which is why we went to segment routing as a way to not do RSVP signaling in networks. So I'm not sure that RSVP signaling for individual flows would ever be a good fit for the large-scale DETNet deployments, but that doesn't mean that it couldn't be a good solution for smaller-scale DETNet deployments.
Okay, I suggest to move on in the queue. Let's hear from Yang a comment.
And regarding the task the tasks that are supposed to be done by RSVP, that task also can be done by let's say a centralized controller. Anyway, that's control and management plan. But I do have one question or one clarification regarding packet forwarding. It looks like to me that when a node, an intermediate node, or every node in the network, when a node receives a packet, then each node needs to identify to which flow this packet belongs. And packet, I mean that the node needs to put the packet to the right queue for the flow. Is my understanding correct?
Yes, in fact, this is what I mentioned when I presented the issue we have with the identification of the flow in the way RSVP does. In fact, in RSVP, you can identify a flow by the typical 5-tuple IP source, IP destination, source ports, destination port, and port protocol. In RSVP, if I remember well, as I need to check, there is a possibility to use flow label in the IP header to help with this identification. But if we use this flow label, we need to make sure that over the path, the flow label is not tampered with. So I think that if we want to identify a flow that is specific, that is a network flow and not a transport layer flow, and we need to stick to IP source and IP destination, and I agree with you, it has limitations. But as I mentioned, we wanted to stick to the format of RSVP to try whether it was possible and probe interest in having other mechanisms in the working group.
Okay, actually, my question is not quite related to RSVP or any other control plane protocol. My question is about data plane behavior. Anyway, you need kind of per flow information
Yes.
in the node, right, to identify which flow goes which queue, right? Okay, thank you.
Yeah, in fact, the reservations are identified by the flow ID that is carried by the message. So we need to have this flow ID identifier somehow to map the flow to the proper queue and make sure that the reservation is consistent.
Okay, thank you.
Thank you.
Yeah, I actually wanted to make similar comments to Tolas, like pretty much all each point that RSVP is not has issues. As he explained, trends and so on. And we have at the first place, we should get consensus on use of RSVP for DETnet at large in the working group. But it's more about data plane enhancements, not control plane.
Okay.
Anyway, I second the points made by Tolas, I would say.
Okay. Point taken. Maybe if it's appropriate, I can present specifically on this reservation protocol aspects in the wider DETNet group rather than in this specific open working group.
Or focus on, like the previous question, focus on the data plane part of your proposal.
Okay.
And make it irrespective of what is used in the controller plane.
Okay.
Okay, we have a Shafu in the queue and 8 minutes left. So Shafu, please go ahead. We cannot hear you actually. You have not turned on the mic. Or at least I cannot hear you. Something is, yeah, I see you have turned it on, but I cannot hear you. Can other people hear?
No, I can't hear Shofu.
Can you hear me?
Yes.
You are now very, very faint, but could you somehow make it louder?
Sorry. Oh, I tried again. Can you hear me?
Yes,
Yes.
it's now okay. Please go ahead.
Okay. Sorry. So my question is that yes, according to the discussion, this proposal is mainly on the control plane. So the data plane mechanism, I don't know if what are the detail about the data plane mechanism. If it relies on the flow receiving, this is my first consensus.
Okay, yeah, indeed, I agree that the way things are presented, things is really focused on the control plane aspects because of the signaling, etc. On the data plane aspects, the goal we had in mind was that the management, the way the packets are managed at the equipment can be very simple while we have something that is enforcing end-to-end delay requirements. And because we see lots of quite complex work with regard to the queuing mechanism, the queuing disciplines, the scheduling, and they require sometimes coordination between nodes. And we wanted to have something very simple on those aspects. But I agree that for now the work that we presented is more on the control plane. So I've taken your remark. Also, Janos and Torres have made remark in the same direction. So if in future versions of the document we will be more precise on data plane aspects.
Okay, thank you. So my second consensus is that according to your slides, that the formula is actually simple. Yeah, but I still be confused that maybe we just change the buffer capacity is not enough to get bounded latency. Because the buffer size, the buffer capacity is not just an attribute of the queue, but it's the size of all aggregated flows that can be permitted to release to the network. That is my second consensus. Thank you.
Yeah, indeed, if you look at the way we manage queues, in the DetNet RFCs, you have a more detailed model for the computation of the contribution of every node to the end-to-end delay. And you have a part that is related to the packet processing time by the equipment, the time that it stays in the queue, the time that the scheduler takes the packet and puts it out on the outgoing interface, and the propagation time on the link between the departing node and the arriving node. We tried to, in our model, we have a constant factor that accounts for the processing time on the node and all the scheduler and outgoing interface time, and we made it only depending on the buffer capacity, because we are in a situation in which the queue is served with a FIFO discipline, and the scheduler of the various queues in the equipment is following a deterministic round-robin policy. So if we use more complex scheduler, for instance, introducing priority or this kind of things, and the queue can be a FIFO with a preemption to place at the beginning of the queue some urgent packets. We need to have a more complex model for the computation of the end-to-end delay depending on the buffer capacity. But we are confident that we can still have a bound depending on the buffer capacity, and this mechanism can be used.
Okay, thank you. Um, maybe I can provide a paper that maybe is related with your proposal.
Sure.
To just use FIFO to get a bounded latency.
Sure, it would be a pleasure to have this information. Thank you.
Okay, thank you.
Okay, we have a very short time left, but I would like to give Kashinat the word or time. So please make your question.
Yeah, just a quick question. Thanks for the presentation. It's quite interesting. As far as I can recall, the RSVP, it has the overhead of the regular refresh messages, path and reservation in opposite direction. And in your work, did you consider using those messages or exploiting those messages to send additional information in order to maintain the guarantees of the path?
In fact, in those messages that are used in RSVP to maintain current reservation, they are limited by the objects that are specified for RSVP messages. And in fact, first and second, in those interim messages or intermediate messages, they all follow the flow that they are sent by intermediate nodes to the destination, and if needed, the destination feeds back information to the source. So this back and forth flow is, to us, introducing delay if you want to react to a change very quickly in RSVP first. And the formatting of RSVP is done to follow the QS work that has been done several years ago. But for DetNets, and especially for this mechanism, if you want to keep a very simple data format, those objects are very tedious to use.
Yeah, there has been some work over the years on reducing, optimizing, or carrying some additional information using those. But yeah, that needs changes to the structure itself.
Yeah. Yeah, in fact, we try to track those changes, but we stick to RSVP objects that were published on the YANA page for RSVP. So once again, we may be wrong, but if you have ID for formats, object formats that we may use, I would be very happy to hear from you. But to the best of our knowledge and from the objects that have been published on the YANA page for RSVP, this is the best we could do.
Okay, thank you.
Thank you.
Okay, thank you very much everyone for the presentations and the good discussion. We are 1 minute, 2 minutes over time, so I suggest to close this call. As David mentioned, the next one is 4 weeks from now, as 2 weeks from now is July the 4th. And we can continue the discussions on the list until the next meeting. Thank you, everyone. Bye for now.